We're going to talk about the distributive property a bit. So we covered the distributive property back in section 1, saying that, hey, it just allows us to distribute things and basically repeat multiplication inside parentheses, or into the parentheses, I should say. So if we have a times b plus c here on the right side, or here on the left side, excuse me, a times b is ab, and a times c is just ac. And we put a plus sign between them because this is positive. Or if there was a minus sign there, it would be AB minus AC, because we consider that to be like a negative C or a minus C. So up here on number 1, we distribute the 7 and we get 7x plus 28. Since we can't combine those like terms, we are done. Or since we can't combine them since they're not like terms, excuse me, we are done. Number 2, 2 times b is 2b. And 2 times negative 3 is negative 6. On number 3, I'm going to go ahead and distribute my negative 4. Negative 4 times y is negative 4y, and negative 4 times 3 is negative 12. So that negative being on the outside changed our signs. Number 4, distributing the negative 5 gives us negative 5m, but here it gives us positive 10. So this is a negative 5 times what we consider to be a negative 2. Now some of us might be wondering, well, wait a second. That's a minus 2. It's not a negative 2. Spoiler alert, they're the same thing, a minus and a negative. So if I call this minus there, I would have minus a negative 10, and 2 negatives in a row without an exponent or without any other terms between them are just positive anyway. Another way to think of it as, or would be to think of it as plus a negative 2, and now we have positive 10 there from a negative times a negative. They're all the same thing. So a good way to think about it is just taking that sign with the number or term. Number 5, negative times y is negative y, and negative times, let me clarify this one more second before we continue that problem. My apologies. We can think of this on number 5 as a negative 1. I should have mentioned. So negative 1 times y would be like a negative 1y or negative y, and negative 1 times negative 9 would be a positive 9, a negative times a negative. Now, another good way to think about that is just changing this to a positive and then changing every sign inside the parentheses to the opposite. So the positive y becomes negative, and the negative 9 becomes positive. And notice we end up with the same result of negative y plus 9. Next, on number 6, as I distribute my 8, I end up getting 32 minus 8b. Number 7, as I distribute my negative 4 times negative w is positive 4w. I do not have to write the positive sign. If I write that beforehand, it's okay. Negative 4 times negative 10 is positive 40. On number 8, distributing 5 gives me 10m minus 15. On 9, distributing negative 3 gives me negative 6x plus 12. We have a negative times a negative there. On number 10, distributing 3 gives me 3m plus 3n. On number 11, x times y is xy. If you wrote yx, that's okay. We typically write them in alphabetical order, so the x would come first. But if you write yx, I'm not going to be a stickler about that right now. X times 4 is 4x. We do want to write the number before the variable though, so be careful on that. Number 12, d times c. I'm going to put cd because once again I prefer them alphabetically, and later we'll be making sure we do that, but for now if you put dc, that's fine. And d times negative 4 is negative 4d. Number 13, 6a times b is 6ab, and 6a times 2c, we do 6 times 2, we get 12, and AC just get tacked on at the end. Number 14, distributing this 2 to 3 different things. We just distributed it a third time. So 2 times x is 2x, 2 times negative y is negative 2y, and 2 times 8 is 16. So all that changed was the number of times we multiplied 2. Same thing here with 15, x times 2y is 2xy, x times negative 5z is negative 5xz, and x times 1 is a 1x, or just x. Next, we have number 16, where we have 1/4 times this parentheses. So as I do this with a fraction, it can be easy to get very messy on this type of problem. So what I'm going to do to be careful here is I'm going to do my work off to the side to keep everything a little more organized. So I'm going to do 1/4 times 8x and put that 8x over 1 because anything secretly divided by 1. It helps to make that second one a fraction now because we can see the numerator and denominator a little more clearly, and that helps us with cross reducing. Diagonally 4 and 8x. 4 and 8 have 4 in common. And so 4 goes into 4 once, it goes into 8 twice, and so we multiply straight across and get 1 times 2x is 2x over 1, which you don't even necessarily need to write, so I can just write 2x. Next, I do 1/4 times -4, which once again I'm going to do off to the side to keep my work more organized, and put -4 over 1, so I have two fractions to work with. 4 goes into 4 once, and it goes into -4 to give us -1. Multiplying straight across just gives us -1 over 1, or just -1. So we end up having 2x minus 1 as our answer. Number 17, more fractions. 1/6 times 3/5 x. So I'm going to do that off to the side. Whether you put that x off to the side or on top of this fraction are the same thing. If it's off to the side, keep in mind that's really x over 1, and so you'd have 3x over 5 times 1, which is just 3x over 5. As we cross reduce, 6 and 3 have 3 in common and become 2 and 1. So on the top we have 1 over, and on the bottom we have 10, and the x one's going to be off to the side or on top. It's the same thing. So I'm going to write 1 over 10x. If you wrote x over 10, that's okay as well. It's the same thing. 1/6 times 18, put that off to the side. Make 18 over 1. Cross reduce, 6 goes into 6 once, and it goes into 18 3 times or thrice. On the top, 3 times 1 is 3. On the bottom, it's 1, so I'm going to just put 3. So we have 1 over 10x plus 3 as our answer. Number 18, for the last part of this problem set, -1/8 times 4/5 x. So I'm going to write that off to the side again. We can reduce 8 and 4 by 4 to become 2 and 1. That gives us -1 over 10x as we multiply straight across. As I multiply -1 over 8 to -24, I'm going to write that out. We can reduce 8 and 24 by 8 to make it 1 over, or 1, excuse me, on the bottom left and -3 on the top right. And as we multiply straight across, -1 times -3 is +3 over 1, or just +3. So we have -1 over 10x plus 3. Moving on to our very last part, distribute and combine. To simplify an expression means to ensure there are no parentheses and no like terms left. So in order to do this, we distribute first if we need to, and then we combine like terms. So on number 19, if we distribute here this 8, we get 16x minus 24, and then we still have that minus 6x afterwards. And now it's like one of the problems we did earlier, where we combined 16x and -6x to give 10x minus 24. Number 20, we have to distribute this 9 to this first parenthesis. 9 times 2k is 18k, and 9 times -4 is -36. We do not continue distributing the 9 because that is a different set of parentheses over here. Now this next part can be very tricky here, so you have to be careful. What I mean by that is this sign tricks people and causes people to make mistakes. What you do not want to do is call this 14k and then drop this minus sign down here, and then call this -24 because it was 2 times -12. That is incorrect. Please do not do that because you will be getting these problems wrong. Instead, what I encourage you to do is make this minus sign a positive and change the 2 to a negative. It's equivalent to the other, to -2, a -2, but it helps us to get our signs correct. So as we multiply through, we get -2 times 7k is -14k, and -2 times -12 is +24. So notice that 24 changed from a negative to a positive from doing it the wrong way to doing it the correct way. So once again, I would encourage you to change this here every single time you're distributing like that, and there's a minus sign, that will help you have a higher chance of getting these correct. Now as I combine like terms, the k's give me 4k, and the constants give me negative 12. Moving on to number 21. Here we have a minus sign before the parenthesis. So just like we did up above, we can change this sign and change the signs in the parenthesis following it to a negative and a positive, the opposite of what they were. Now we do not change this sign because it's not in the parentheses. So now as we combine like terms, negative y and negative y give us negative 2y, because those are both negative 1y's, and 10 and 6 give us 16 as our answer. 22. We have to distribute the 8, so I'm just going to rewrite the 6 because we're not doing anything with that. And 8 plus 4w is a 30, or 8 times 4w is 32w, and 8 times negative 7 is negative 56. Change these signs, make your life easier. Make everything in the following parenthesis the opposite. Negative 2w minus 1. Combining the w's gives me 30w, and combining the normal numbers, the constants, gives me negative 51. Now on 23, we get the pleasure of dealing with some additional fractions. How exciting. So as I do 9/4 times 10/3 x, I'm going to write this off to the side again to make my life a little bit easier by getting more organized. Organization is huge in math, and I highly encourage you find some good methods of organization, such as the ones I'm presenting. Diagonally 9 and 3 reduced by 3 to become 3 and 1, and diagonally 10 and 4 reduced by 2 to become 2 and 5. We multiply straight across and we get 15 over 2 times x. And once again, you could put the x on the top of the 15 as well, or leave it off to the side as it is now. So 15 over 2x. And we do 9 over 4 times negative 4. So 9 over 4 times negative 4. I'm going to put that over 1. And 4 and 4 reduce to 1 and negative 1. And give us negative 9 as we multiply straight across. So minus 9. And now as I distribute this 1/4, I'm going to make it plus a negative 1/4, like I talked about earlier on problem number 20, to help make sure I get these correct. So negative 1/4 times 2x. I'm going to do that off to the side again. Put 2x over 1, look to cross reduce, 4 and 2 become 2 and 1, and I get negative 1 over 2, and you can put x on top or x off to the side. Because I put x off to the side earlier, I'm going to stay consistent and do that again. Now as I'm going to rewrite that too, that turned out very poorly. Now I distribute this negative 1/4 to negative 8. Put that over 1. Look to cross reduce, 4 becomes 1 as we divide by 4, and negative 8 becomes negative 2 as we divide by 4, and we get negative 1 times negative 2 is positive 2. Now I combine like terms over here after all the distributing is finally done. 15 over 2x and a negative 1 over 2x. Thankfully, they're common denominators. If not, we would have to get common denominators. But when we have common denominators, we just simply combine the numerators and leave the denominator and variables the same. So 15 minus 1 is 14 over 2x. Negative 9 plus 2 is negative 7. However, there still is more to complete because we can do 14 divided by 2, and that just gives us 7. So it's 7x minus 7. So thankfully, after all of that fraction mess, we end up getting a nice answer with no fractions. Turning on to 24 to get even more fractions. Once again, incredibly exciting, I'm sure. 7 over 8 times 4 over 5. I'm going to do it off to the side to give myself some room. 7 over 8 times 4 over 5x. Look to cross reduce. 8 and 4 reduced by 4 to become 2 and 1. 7 and 5 don't reduce though, so you get 7 over 10 times x. 7 over 8 times 16, so I'm going to write that off to the side again. Put 16 over 1, and 8 and 16, 8 goes into both. 8 goes into 8 once, and it goes into 16 twice. Multiplying straight across gives us 14 over 1, or just 14. Distributing my 3/5, I don't have to change the sign because it's already a positive. So 3/5 times 1 over 2x. Nothing cross-reduces here, unfortunately, so we have 3 over 10 times x. And last but not least for distributing, 3/5 times negative 10, which I'm going to put over 1. And 5 and negative 10, 5 goes into both, 5 goes into 5 once, and negative 10, negative 2 times. Multiplying straight across gives us negative 6 over 1, or just negative 6. Now, as we look to combine like terms, 7 over 10x and 3 over 10x, once again, thankfully have common denominators. So we add the numerators, 7 plus 3, and get us 10 over 10x. We might notice that reduces, which we'll do in just a moment. 4 minus 6 gives us negative 2. As I mentioned, 10 over 10x does reduce. 10 over 10 is 1, so we have 1x, or just x minus 2. And that is all for section 1.3 of Algebra 1. So let's start off with some keywords and phrases. And the reason why we're doing this whole section, especially this first page, or these 6 boxes, is because a big struggle point for many students are word problems. And that isn't necessarily just because of the equations associated with word problems, rather than writing those equations and how to start it. And translating all the words into math can be a very challenging aspect of it. And so to try and aid in that, I want to give a bunch of different examples of, hey, if you see this word, it means blank, as far as what operation to do. So some words that mean to add would be the word sum. Sum means the result of addition. Or total, the total number of blank, or they total this. Plus, which is just literally the symbol is a plus sign. The word increased by. And the phrase more than. Now, obviously this, or maybe not obviously, but this is not an all-inclusive list. Not every single word that could ever mean that you add in a problem is included here. Such as the word add. You could say 5 added to 12. And that's not listed here, but of course that means addition, since it literally says add. Now let's talk about subtraction here for some different words. And the first one we'll talk about is difference. Similar to sum, it's the result of the problem. In this case, it's just result of subtraction. Minus, the minus sign. Decreased by. Less than. And subtracted from. And I'm going to put a little star next to less than and subtracted from. And I encourage you to do the same thing. And I'll talk about why we'll do that in just a little bit, a few boxes later. Moving on to multiplication. Multiplication, some words would be times. Or product. The result of multiplication is the product. The word of, such as 5/3 of 17, or that would be a terrible problem to actually do, but 5/3 of whatever, or half of 12. It means 1/2 times 12. Twice, or thrice, or anything like that. And then similarly, double, or triple. Different phrases like those. And division, quotient, which is the result of division. Separate, which I always remember how to spell separate thanks to a college professor, for it has a rat in the middle. Divided by. Split up, like the gang in Scooby-Doo does. And half of this, or half of would be multiplying me of, but using the phrase half compared to split up or divided by would also mean division. So half, third, fourth, fifth, sixth, etc., etc. It's the same exact thing for all just these different numbers specifically. Parentheses phrases. So if you see these phrases, put that in parentheses, or put something in parentheses here. So if you have something times or divided by the sum of, and sum, once again, just means addition, but result of addition more specifically. So it's like saying if I have 5 times the sum of 3 and 2, we have to add the 3 and 2 first, and then the result of that, the sum of that, gets multiplied. Not just 5 times 3 plus 2, which means that we do 5 times 3 first, rather than adding first. And if you were to see something similar, times or divided by, the difference of is just the other side of the coin, where difference means subtraction, and so it's a result of subtraction. So if I were to just change this to a subtraction symbol, we could use the exact same example of saying 5 times the difference of 3 and 2, meaning we subtract 3 and 2 first, and then the result of that gets multiplied, instead of 5 times 3 first minus 2. Now another phrase I'm going to include here is whenever you see the word quantity or the quantity, especially the quantity of. It's an optional one, so like the quantity of. So for example, I do this quite a lot, actually. This is the most common one I use. And the reason why it's the most common one I use is because it's not specific to a certain operation. You don't have to add because you said sum. You don't have to subtract because you said difference. It can be any operation. And so whenever you say the quantity of, we're just saying whatever follows is in parentheses. So to use quantity with this early example, it'd be the quantity of 5, let me try this again, 5 times the quantity of 3 minus 2, telling us whatever comes after quantity of is in those parentheses. So once again, that'd be like 5 times the quantity of 3 minus 2. Once again, you have to specify the operation because it doesn't automatically mean a certain one, like sum and difference of. So it's more versatile, but it does require you to specify the operation. Turnaround phrase. So you may remember we starred less than and subtracted from. And that's because they're what we're going to call turnaround phrases. So here we have less than and subtracted from. And when we go up to our subtracted part, or subtraction part, I should say, whenever we see the word, any of these words, or any of these other phrases all throughout here, we write the numbers and we do the numbers in the order we hear or read them. So for example, if I were to say 5 plus 2, I put 5 first and I put 2 second. If I say 10 divided by 5, I put 10 first and 5 second. And if I were to say 5 minus 8, 5 minus 8, we do 5 first and 8 second and get negative 3. So we do it in the order we see it or hear it or read it. Now, if I were to say, though, what is 3 less than 2? What is 3 less than 2? Well, what we're really saying there is we're supposed to be doing 2 minus 3. 3 less than 2 is telling us to take 2 and then subtract 3 after the fact. And so we end up getting negative 1. Also, if I were to use subtracted from, it's the same exact idea. Or if I were to say 3 subtracted from 2, we're telling us we are subtracting 3, and that 2 comes first because we're subtracting 3 from that 2. That is, what we're subtracting by is 3, what we're subtracting from is 2. So those are unique phrases where we have to turn around or flip the order we see those in. So now let's go into some examples. So we're going to translate each of these expressions or equations, and we're only translating. We're not going to solve, we're not going to simplify or anything like that. We're going to put it into numbers and call it good. Now, something I need to know is all of these will say like a number. And when it says a number, it's not asking you to pick a number like 12 or something. It's instead asking you to make it a variable. So anytime we say a number, we mean a variable. And so you get to pick whatever variable you want to put there. Most common one is x. A lot of times people might put N for number even. But realistically, if you have a favorite letter or you really want to do a certain letter, you're more than welcome to, unless it specifies that it's a specific variable, like the product of a number X or the product of X, or things like that. Now in number 1, we see the word product. Product tells us that it's multiplying. So what two things are we multiplying together? A number and 3. Now, even though we see X first and 3 second, and that is not technically incorrect from the standpoint of it means the same thing as if you were to flip it around and put 3 before the X, we want to write the number first and the variable second. That's how we're going to be writing it this entire year. So we want 3x, even though, once again, we see a number come first, and I spent all this time talking about these turnaround phrases. But remember, the order doesn't matter when you multiply. That's the commutative property, that we can flip things around, and that's okay. 2, the difference between a number and 10. So we're subtracting, and then it's the a number x minus 10. Now notice difference is not one of our turnaround phrases, so we did it in the exact order we saw. We did the number first, the variable first, and then 10 second. Next up, number 3, the quotient of a number and -5. So we're dividing here, and so this is some variable divided by -5. And you might be wondering, Mr. Kossel, could I have done this as a fraction? And the answer is, of course you could. You can do x over -5, and it's the same exact thing because fractions are just division problems. Next up, we got number 4. 4 subtracted from a number. Subtracted from. We should have alarm bells going off in our head right now because that's one of our turnaround phrases. That means subtraction. So we put a number first. The second part comes first here, so that's x minus the first part, 4. Once again, that's because this is one of our turnaround phrases. Less than and subtracted from are those two. Number 5, the sum of twice a number and 7. So we're adding twice a number and 7. So twice a number is 2x, and we are adding that with 7. So notice when you see the word and following sum or difference or product or quotient, that and is telling us where the sign goes. So we know it's plus because it's sum, and we know where it goes because of the word and. So we put twice a number, 2x, adding with and the 7. Number 6 here, the product of a number and 10 increased by 1. So product means multiply. What are we multiplying? A number and, once again coming in, 10. So we're doing 10 times x, which once again we prefer to write that variable second and the number first for multiplication, increased by 1 now. So we put plus 1. Now, if you see a comma, that means that whatever precedes or comes before the comma has to be the first thing we do in the order of operations in that problem. The first thing we do math-wise there. So if that were to come later in the order of operations for whatever reason, then the part outside the parentheses or after the comma, then we need to put it in parentheses. So for example, product automatically comes before addition, so we don't need parentheses here. But if it were to say the sum of, that would automatically mean parentheses as well. So if it were to say a number plus 10, instead of increased by, it'd be times by 1. Then we would end up doing the number plus 10 in parentheses, and that's 10, or times by 1, would be outside the parentheses. So we'd have to multiply first here. We add first here. I keep mixing my words. We'd have to add first here in this scenario because that comes before the comma. Just like in the English language, the comma means that you pause. So we do the first part. We do a number plus 10 in this scenario where I changed it to plus. We do that first, pause, so do that, and then multiply by 1. But once again here, it didn't end up mattering because regardless, multiplication will always come before addition. So if you put that 10x in parentheses, cool. If not, also cool, because it doesn't matter, because the order of operation tells us what to do there, and it's the same result. Moving on to number 7. Number 7, 4 less than a squared number. So less than, that's an alarm bell, right, going off there, because it's a turnaround phrase. And so we're subtracting something minus 4. So what is being subtracted by 4? Because 4 came first, so meaning it comes second here. A number squared, so some variable squared, minus 4. 8, twice a number divided by 5. So twice a number, 2x, or 2 times your variable, divided by 5, which once again you could either do like this, or you could do like this, and I really do not care. The sum of twice a number and 10 is 36. So now notice we saw is. That's an equation. So anytime you see the word is, that's going to be your equal sign. So is means it's an equal sign. And I can't really use the equal sign between is and the equal sign here off to the left, because then that would look really odd if I just write like this, is equal equal, or I write out the word is equal sign. None of that really makes a load of sense there. So the sum of twice a number and 10. So adding 2x plus 10, remember that and tells us where that sum, the addition sign goes, is or equals 36. So the only change here is that we add it, or we set it equal to 36. We don't have to solve though, we're just setting it up here. Number 10. 3 times the difference of a number and 7 is 18. So this is 18, tells us it equals 18. So what equals 18? Well, 3 times the difference, remember difference is subtraction, it tells us it has to go in parentheses. So what are we subtracting? A number, so x, and that's our minus sign, 7. And we're doing 3 times that, so this 3 is going outside the parentheses. And if it's outside the parentheses, that automatically means it's multiplying, so I don't need to put any symbols there. Number 11, 4 times a number divided by 8 times 3. Excuse me, try that again. 4 times a number divided by 8 is 3. I said times 3. So 4 times the number, so 4x divided by, so either put it over a fraction or use a division symbol. Once again, either one is fine. Is or equals 3. And these are all equations we certainly could solve once we learn to solve them, and maybe you already know. And good for you if you do, and if not, that's okay. We're teaching it next unit. But regardless, we're not solving them here today. Number 12, 5 times the sum of a number and 6 is 48. So 5 times the sum, remember sum tells us result of addition, so we're putting that in parentheses. The number and 6, so x plus 6 is or equals 48. As I'm mentioning sums in parentheses, I want to go back and just emphasize something that on number 5 here, it said sum and we didn't put it in parentheses. And I realized some of us may be wondering, well, why not? Well, here's the thing. The only thing we have in this is addition besides this multiplication here. So if I put this in parentheses, it doesn't impact it because there's nothing outside the parentheses on this problem. Whereas on the problem we just completed, there is in fact something outside the parentheses. So that impacts it and requires or necessitates the use of parentheses. Number 13, 1/2 of a number is 8 less than the number itself. So 1/2 of a number, so 1/2 times x, is equals 8 less than the number itself. So less than, alarm bell going off in my head. So the second part will come first, the first part will come second. So we're doing something minus 8. So then it says, to end the problem, which would come before the minus sign, the number itself. So that tells us that we're actually using the same exact number as before. We're using that same variable. So whatever variable you pick early in the problem, you're picking that same variable here, because it says the number itself. Now I want to note, if it were to say less than a different number, then we'd have to change the variable. So if you put x first, maybe put y second, or some other variable that's not x. So if it were to specify a different variable, we have to change it. If it specifies it's the same variable, we have to keep it the same. Number 14, the product of a number and 3 is the same as the sum of that number and 6. So we see our is, that's our equal sign. So before the equal sign, the product of a number and 3. So 3x. After the equal sign or after the is, the same as the sum of that number and 6. So we're adding the same variable and 6. And we could put parentheses since it's a sum, but there's nothing outside the parentheses on this side of the equation, so it's not necessary. So even though this 3x is outside the parentheses, it's on a different side of the equal sign or a different side of the equation, so it doesn't matter. And so I often just won't write the parentheses because they're extra, but if you put them there, it's not wrong. Number 15 here, 15 decreased by the quotient of a number and 3 is 20. So decreased by is not a turnaround phrase, so we just go in order. 15 minus the quotient, so division, a number, and 13. So x divided by, not 13, but x divided by 3 is or equals 20. So we're just kind of going in the order we see it, unless we see a turnaround phrase, and going as we just see the problem otherwise. 4 less than, turnaround phrase, so something minus 4, okay? The product of a number and 7. So we're doing the product of a number and 7 minus the 4, so less than the product. So we have to multiply before subtracting, which is normal for how that order of operations goes. So a number and 7, so 7x, then is 8 more than that number. So 8 plus that same variable x. Once again, emphasize it's that same number here. Now let's get into inequalities. So our 4 inequalities are the less than symbol, the less than or equal to symbol, the greater than symbol, or the greater than or equal to symbol. And so we're going to use these inequalities as we continue on for our last 10 examples of this lesson and unit. So number 17, a number is less than negative 10. So x is the number, is less than. So is less than is different than is or is equal to. So we have to put the less than symbol, negative 10. And we just do it exactly the order we saw it, replacing the words with the symbols. 18, a number is less than or equal to 8. So x is less than or equal to 8. Number 19, we have a number, so x is greater than or equal to negative 4. And that's the problem. Number 20, a number is at most 45. So x is compared to 45, but at most. We don't see any of these that say at most. So what does at most mean? Well, at most means the highest it can be is that number, but it's possible it's lower than that number. Meaning, we're saying less than or equal to. So the highest it can be is 45, or it can be less than 45. Number 21, a speed limit of 55 miles per hour. So a speed limit means that that's the highest it can be. So very similar to number 20, we're saying at most it can be this number. So x is less than or equal to 55. So even though this didn't have any a numbers or anything like that, or saying less than or equal to or at most or anything like that, we still can infer or see from this problem that we're saying it could be a range of numbers. So think about driving on a highway or road where the speed limit is whatever number it is. You can be that speed or lower than it to legally be within the speed limit. 22, a number is at least 16. So x compared to 16 somehow, we got to figure out what symbol. So at least gives the idea that the lowest number it could be is what's provided. So the lowest we can be is 16, or we can be greater than it. So it can be 16, so it's an or equal to, or it can be greater than 16. Number 23, a number is no less than 10. A number is no less than 10. So we see less than, and we're like, oh, it'd be a less than symbol. But not quite. We have to read in the context. A number is no less than 10, meaning the lowest number we're okay with is 10, or we're okay with more. So that's greater than or equal to, actually. So even though it says less than, and that might be tricky to us, we have to read into the context there, saying no less than that, aka your grade in order to pass a class must be no less than 60. We're not talking about numbers lower than 60 passing the class. We're saying 60 or above or greater is passing the class. Number 24, a number is no more than 26. So that'd be like I'm saying you can retake no more than X amount of tests, which is something we apply in future semesters of math after the first semester of Algebra 1. But no more than means you can take less than that amount or that amount, so less than or equal to, but that's your cap or your limit. And the last two here, a maximum number of 25, meaning the highest we get is 25, or we can be lower than it, so that's x is less than or equal to 25. And then a minimum number of 5, meaning we can be bigger than 5, or we can be equal to 5. So that wraps up our 1.4 lesson for today, and that wraps up our unit as well.